Hi everyone, it's Bash, and today we have a new episode of Code Explorer where I dive deep into the code of a project that I've worked in the past and essentially explain how it works at a very technical level. So in this episode, we're going to be explaining a project called Muse Monitor, which is something I worked on 7 months ago for a application development contest when I was a sophomore. And essentially what Muse Monitor is it's a system that utilizes the Muse Headband biomedical device, and it uses data from the device to detect neurological and physical events in potentially hospital patients, and these events include seizures and also falls. Really, this is getting into automating emergency detection. So, for example, we wouldn't have to call 911 or press a button to alert emergency authorities. That would be done automatically through IoT biomedical devices. So now, as an introduction, this is the Muse Headband. If you haven't heard of this before, it's usually used for meditation to improve your meditation, but it can also be used for developer purposes. So if you can see from here, these are the EEG strips which record the brain activity from certain areas of your head. This also has an accelerometer and a gyroscope to record acceleration data and also orientation or angular velocity data as well. So now with that, let's get into the demonstration. So here, if you look on the screen, we have the Android application, which is used to retrieve the data from the Muse Headband and also take that data and stream it into the server. So here I have the Android device, but you can also see it from the screen as well. So since we are a patient, let me first click patient. All right. If we are registered, we can enter the patient ID or the patient name. But since we're not, let's register a new patient. So I'm just going to put in my information. All right, doctor 123. All right, there we go. Register, and then this should take us to the streaming page. Now this is the page where we will connect to the Muse Headband, and this is also the page that will retrieve the data from the Muse Headband and send it off to the server, which I will get more into once we get into the code. So this is the Muse Headband. Let me turn it on real quick. There we go, and we should see it appear on the screen. So now let me tightly secure it around my forehead, and we will go ahead and connect. And it will take a second to connect. Once it does, we will now see that the data being displayed on the screen, which indicates that it's successfully retrieving the data from the Muse Headband, and it will also take this data and send it to the server. So now, if we look at so now just a little bit more technical. So the Android is taking the data from the Muse Headband and it's putting it into the server, and now the server is taking that data, analyzing it, determining if there's any sort of medical events, and then it will stream that data, those results, onto this web application that you're seeing on the screen right now. So let me go ahead and refresh. So we should see a new patient, which is the one that I just registered. I will go ahead, click that, and this will view more information about the patient. So we have everything that we already inputted. And then now we will be able to see the acceleration data, the gyroscope data, and also the EEG data in real time. So to demonstrate this, if I move left and right, looks a little bit weird, but just to demonstrate the acceleration, as you can see, it changed a little bit when I did that. Now to demonstrate the gyroscope, so if I tilt my head, you should see it change a little bit too. Now for the EEG data, this is a little bit harder to demonstrate, but usually they say that when you clench your jaw, this will interfere with the EEG data being emitted, because it's like the muscular contraction or whatever. So let me just wait until it's calm a little bit, so let me stop talking, and then I will begin to clench my jaw. There you go. If you see right there, this is when I clench my jaw, and as you can see, it reflected in the EEG data appropriately. So now to demonstrate the medical events, first we will do a fall. So let me just go ahead and just pretend to fall a little bit. It's going to look a little bit weird, but hopefully it will work. So let me just jump up and down, fall a little bit. There we go. We have the notification on the bottom right. We had the physical status change on the top, and then we had the status being inserted into this table for reference. And we have the time and the status description and all that stuff. So now to demonstrate the seizure, which is obviously a little bit harder to test since I just can't get a seizure at will, but I did think about this for demonstration purposes. And if you look back at the Android application, so let me go ahead and open that up for you guys. I added a feature to where it can override the, okay, ad's going to appear in a few seconds, but I can just exit out of that. But it can override any data that's being emitted from the Muse Headband and instead stream the data from a file. So what I've done is I downloaded a bunch of files which has EEG data stored from patients who had seizures. So we will predict that if I stream the EEG data from one of these files, we should get a true positive for a seizure. So let me go ahead. I believe this is a file that has patient data for EEG. Let me reconnect. I think it disconnected for some reason. Probably when the advertisement appeared. So now let me start file stream. So if you look here, you will see a change. So as you can see, it's only for one channel. It doesn't have the test data for all 6 channels. But now if you look down here, we should see that for the channel, we have the EEG data that's being streamed from the file instead. Pretty soon, you'll be able to see a notification on the bottom right, indicating that the seizure has occurred. And then right there. And then if you look on the top, we see the mental status is a red X, and we see that we've entered a new entry in the table. These statuses also work if you go back into the main page. So let me just do a little bit of a quick fault real quick. There we go. We see the notification still works, and now we can also see the status changed in the main page. So if you have a nurse who is responsible for multiple patients, they will be able to see all the status for all their patients at once. And then if they want to look at more information, they will just go ahead and you know, click on one of these pages, right? So now let's get into the demonstration. So this application that I made, this system, is the first project that really consisted of multiple different components. So I have the Android application, I have the web application, then I also have any services that is stored on the server. So the point I'm making is that the best to understand the system is going to be worth it to first understand the high level and abstract view of the technical architecture and how each component in the architecture communicates with each other. So I had this illustrated on this technical diagram. So here is the Muse Headband. This box right here is the Android application, and this box are the backend services, and here is the web client. So I won't get into too much detail, but as you can see, this is the Android application. We have 2 activities. Activities are essentially Android pages. So you have the patient form activity, and we also have the patient streaming activity. So the patient form activity, what was the activity that you can register or retrieve the patient information, right? So when you can put in the patient ID or patient name, or whether you have to put all the patient information and click register. The streaming activity is the one after that, where you can connect to the Muse Headband, where you can connect to the Muse Headband, and also stream the data from the Muse Headband onto the service. So that is the streaming activity, right? And that's illustrated by these 2 boxes down here. So for the form activity, what we are doing is we either have to retrieve the patient information if we are logging in, or we have to post the patient information in case we are registering the patient, right? So that is facilitated through this REST call. So the patient form activity is making a REST call to the patient REST service, and the patient REST service is the web service that's actually retrieving or registering information. So where it retrieves and registers information is the patient Mongo database via the MDB protocol. The Mongo database, you may be familiar of SQL databases. The Mongo database is a NoSQL database where it stores all this information with JSON documents, okay? So that's the connection between activity and service. Now let's go into the streaming activity. So it will connect to the Muse Headband via Bluetooth LE, that's low energy, which is a new version of Bluetooth, and it will stream the data from the Muse Headband via Bluetooth LE, and it will stream that to the STOMP service, which is a WebSocket service. So the difference between STOMP, the STOMP protocol, and you may be familiar with the HTTP protocol. HTTP, all it does is request response. You just send a request and you get a response back. That is inefficient if we are sending a lot of data rapidly and continuously, such as the Muse Headband. What the WebSocket protocol is, and I'll get to STOMP later, what the WebSocket protocol is instead of request response, it's subscription, right? So you are subscribing to a channel and you can stream data back and forth. STOMP is just one layer above WebSockets where we'll add more formatting and conventional attributes to that WebSocket message, okay? So that's what's going on here. The streaming activity is streaming the Muse data to the STOMP service. And the STOMP service is what's actually doing the analysis on the data, okay? So let's get into the web client. So forget the login page. I didn't end up doing the login page. But here we have the patient list page, which is this page right here. Excuse me. And then we have the patient details page, which is this page right here. Right? This is the patient details page, which shows all the details of the patient. As you can see, the STOMP service is sending its data. So I'll get to data later, but it's sending data via the STOMP protocol, so you know there's streaming going on. It's sending data to the patient list page and the patient details page. As you can see, we have two connections occurring, okay? We have two connections occurring. One connection are for the Muse indicators. So what this channel is it will send information with the indicators, and the indicators are very simple, is do you have a seizure or not, or did he fall or not, right? So there's not much data. So if there's any web page that only needs those two pieces of information, it's just going to subscribe to that channel, okay? Now we have the verbose channel, which will not just send the two indicators, but also send the EEG, acceleration, and gyroscope data as well. So as you can see, that is being used in the patient details page, which is when we have the plot and we are visualizing the data itself, okay? It's not showing because I don't have the Muse Headband connected. So that's why there's only a one-to-one connection between the STOMP service and the patient details page. For the indicators, that's being used on these two status indicators on the website, okay? So we need the indicators so we can appropriately have the green check mark or the red X. That's for both, for one in the previous page and then also for these two indicators on the details page, okay? So that explains these two connections. But now there's one other thing. How do we get the patient information? So as you can see on the details page, we have this information, right? We have all the patient information. Well, that's being stored on the patient Mongo database. So how do we get it onto this page, right? Dynamically, okay? So this will take some understanding of how, web servers work. So when a browser or client requests an HTML page, so when they just put in this URL, they are sending a request to the server, okay? The server will take a look at the URL and they'll be like, okay, so we need the appropriate HTML file for the patient's URI with the path parameter of this patient ID, okay? So we have those two pieces of information, okay? So that's still on the server, okay? Then the server will find the correct HTML page, so that's the patient details.html page, and it will then populate any sort of variables in that HTML page. Okay, so we have HTML and then we have server HTML, right? Specifically thime leaf, but we'll get into that. So before it actually sends the HTML page, it's going to look at any sort of variables that needs to be populated in the server HTML page, and it will populate that. So in this case, it's going to populate the patient information. So when it's rendering the HTML page, it's going to make a REST call to the patient REST service, as you can see here. So this is the MVC service that's doing all that logic. It's going to make a REST call to the REST patient REST service, and then that's going to retrieve the data from the Mongo database. And then once the MVC service, so MVC is just a fancy name for what it's called. Once the MVC service retrieves that patient data, it's going to populate it in the server HTML page. It's going to finalize that server HTML page into just a regular HTML page, and then with that regular HTML page, it's going to send it back to the client or browser in this case. It's going to send that finished HTML page to the client, and that's what we see right here. Okay, so that's what goes behind the scenes when you simply put in the URL and you get a web page back. So all that logic occurs, not just for my example, but for pretty much every single web application that's out there. Okay, that should describe the whole architecture. Now we can get into the code. Let me tell you that there is a lot of code in this system, so I'm just going to briefly go through the generics of it. Okay, let's see how we're doing on time. All right. So 9 minutes into the explanation. Okay, so now we're going to start with the Android code. So let me pull up the code, the activity code right there, and let me do it a side by side with the design. Okay, so for Android we have mainly two aspects that happen. Okay, we have the activity Java files and we have the layout XML files. The layout XML defines the layout, obviously. Okay, so here in the right is the user activity. So when you select patient or nurse, right, this is the layout.xml file, or I should say what it's converted to. Okay, so this is what it looks like. This is the actual XML file, but I won't bother to go into detail on that. Let's just worry about the design. Okay, so this is modeled through XML, right? Simply we have a text view and then we have two buttons. Okay, not much going on in the design. Let's look at the activity for the user activity, right? Not much going on. So what will happen is we'll put a click listener. So when you click the button, it will call this code. We're going to put a click listener on the patient button. We don't have anything for nurse because there's nothing that happens. I didn't put any logic for that. So for the patient button, okay, what will happen is when patient button on click, we will go to patient activity, the method go to patient activity, and self-explanatory, we will make an attempt to go to the patient activity class. So now when you click patient, all it does, go to another Android page. Okay, let's go to the patient activity. Okay, and let's see the corresponding layout.xml file. So let me open that up. Wrong one. There we go. Okay, patient activity. Okay, so here's the patient activity. There are a lot of Android layout components in here. So we have a bunch of edit text, which are these text boxes. We have a bunch of buttons and all that stuff, right? So the first thing we do in the patient activity, so let me go all the way up, is we have to init the UI. So when we create the activity, we want to init the UI. This is where we do all our configuration for the layout. Really, the main thing are two click listeners. This is the two main parts of this application, are two click listeners. So when you click a button, it will call this click listener code. Okay, and those two click listeners are the two buttons that we have on the page. We have login button and we have the register button, which is kind of cut off, but you can look on the right side. We have login and we have register. Okay. The two main pieces of code is what happens when we click these two buttons. For the search patient button, which I think is the login button, so if I click this, yeah, search patient button, that's it. So when we click that button, it's going to run this code. It's going to retrieve the edit text data, so from these two boxes, the patient ID and the patient name, and it's going to check if these two are actually entered. Okay, if the patient ID is entered, we're going to make that REST call. So going back here, we're going to make that REST call to the patient REST service to retrieve the information. via the patient ID. There's two ways you can retrieve data, via the ID and via the name. So if the patient ID is entered, we're going to do it via the ID. And then if the patient name is entered and the patient ID is not, we will search based on the name. So we're going to make a REST call. If both of them are not entered and we just happen to click login, we're just going to make a toast notification that says no ID or name is entered, so enter it again. Okay. So now these two are objects which actually facilitates the REST call. I won't get much into that, but just know that they will actually do the communication. If you want to look at more details on this code, you can look at the GitHub project, GitHub repo that contains all this code. The link will be in the description. Okay. So that's the patient activity. Now let's go into the streaming activity. So after we make that REST call inside that patient task object that I showed you before, let me go back to that. So where is it? Okay, there we go. Not there. Oh, okay, here we go. Yeah, right here. Patient search by ID task and patient search by name. The two things that these two do. So I'll talk about them a little bit. Once you enter the patient ID and you click login, it's going to call this. Okay, just so we're back on track. This patient search by ID task, what it will do are three things. Number one, it will search for the patient information via the ID, or in this case, via the name. Okay. The second thing is it will store the patient information into the shared preferences object. What the shared preferences is if we go to the Android documentation, it's the storage options, it stores primitive data in key value pairs, but really the value of that is it will store data that can be accessed across all activities or all pages in the Android application. Instead of just like making a variable, if you just made a variable, you can only access that within the activity itself. But for our case, we can now access the patient information throughout the whole Android application because we're going to actually need the patient information when we get into the streaming activity. As you can see, there's other ways you can store data on Android. So. Okay, but that's the second thing. So the first thing is it will make the REST call to search the patient based on ID or based on name. The second thing is it will store that information that's been retrieved, and it will store that on the shared preferences object or container. And then the third thing is it will redirect the streaming activity if the previous two steps were successful. Now for the register patient button, okay, it's kind of the opposite. Okay. So instead of retrieving patient information, we are creating the patient information based on these five text fields. Okay, so we're going to create a patient object, and we're going to send that patient object to the patient REST service via HTTP REST. Okay, so that's what goes on in this click listener. I won't go into too much detail, but that should be enough. So it does similar things. It will register the patient, it will store that patient information into the shared premises, and then it will go into the streaming activity, which is where we're at now. The streaming activity is a bit more complicated. I will go into it real quick. So if we go into the init UI, so init UI is what initiates all the user interface. This is the user interface layout.xml. So that's what the init UI does. So we can go into that. So it will just set all the click listeners for all the buttons, as you can see in this piece of code. Then it'll also configure the spinners, the two spinners we have. And another name for spinners are drop-downs, and we have the connection, the Muse connection drop-down right here. Then also the file stream drop-down. The second thing that happens in the onCreate method is it will initiate the STOMP connection. And that's what goes on in here. We'll talk about that more once we get into WebSockets. And then after that, it will make an async, another thread to actually update the information on the web page, and then also send the information to the socket server, the WebSocket server, or the STOMP socket server, STOMP server. Okay. and that's what goes on in the tick UI and socket runnable object. So as you can see, it will send packet to UI. So that's what happens in here. It will send packet to the socket, to the WebSocket, and that's what happens in this method. And then yeah, that's what occurs. And then there will be, I also have other logic. So one of it is a click listener for the start file stream. So let's look at the click listeners for real quick. And just to remind you, these click listeners are what occurs when we click a button. So let me go search that up. Okay, so these are click listeners. So when we click a button, the first thing we do is we have to determine which button was clicked. So if it's a refresh button, we'll run this code. So stop and start. If it's connect, we'll run this code. If it is disconnect, we'll run this code, pause, etc., etc. But this is the interesting one. So the EEG data button is this button. As you can see, it highlights this, the EEG data button. So when we click the EEG data button, or the start file stream button, probably not the best name to give it, what we'll do is we'll determine the selection, and we will extract the information from the appropriate file that was selected. So here are all the files and the assets. So this is just an example of what it looks like. Just a bunch of lines of EEG data values, so about 4,000. And let's go back. And it will add that data from the file, put it in the EEG data list, and instead of getting the information from the Muse Headband, it's going to get it from that list. And I have some booleans and some logic to facilitate that. But this should be, for the most part, the logic that's contained in the streaming activity. So therefore, we've concluded the code for the streaming activity. The next thing we will go to is the patient REST service. So we've completed the mobile client. Now we're going to go to the patient REST service and see what that's like. And it's going to be a lot more simpler. Okay, so let me put that up here. So here's the patient REST service code. Not this one, but let me pull it up real quick. Here is a controller. So the controller for patient REST services are what defines the endpoints. Okay, so you can make a REST call to several different endpoints in this controller. So for example, we have the register patient endpoint, which can be accessed by this URI and this HTTP method .post. We can also retrieve patient by ID. So that should sound familiar, and that can be accessed through this URI and get method. We can also get it by name, and then this is just retrieving all patients. So this is used on the patient list.html page when you see all the patients. This is the endpoint that's being used. This is being used when on the Android application when we search by name. This endpoint is being used on the Android application when we search by ID. And this endpoint is being used when instead of logging in, we have to register a new patient. So as you can see, it accepts a patient object, and we will appropriately map it, and we will go to the patient repository and register that new patient, which is facilitated by MongoDB. As you can see here, this is it uses the repo, patient Mongo repository, and it will save the patient or find the patient by Mongo.id, or find the patient by name, or repo.findAll. So there's a one-to-one relationship between the Mongo operators and our endpoints. So very, very simple. Actually, that in fact concludes the REST service. There's really not much to it. It was very simple to build. I think I built this whole service in like 20 minutes or something like that. So the next part is we're going to go into the socket service, and this is going to be a little bit more complicated because, like I said, not only does this facilitate the streaming activity that's occurring between the Android application and the web client, but it also contains all the logic to analyze the data and determine the indicators. Okay, so this is going to take a little bit of time, but it should go well. Okay, so this is the project for the socket server. So this also has a controller file, which has one endpoint. Okay, so the Muse payload endpoint. Essentially, what this is if anyone wants to send data to the service, they will have to put this in their message. They will have to indicate that this is a proper URI to stream the data to this socket service. Okay, so once we retrieve the data as an inbound payload, we will add it to a queue, and we will determine the fall. We will determine if a fall is detected or if a seizure is detected by these two booleans, and I will get into these processors in a moment. Okay, and then with those results, we will attach to an outbound payload. So we get the data from the Android application. Now we have to send the indicators to either the web client. Okay, so we need to define that information on what to send to the web client. Those are these two payloads. Okay, and then once we do that, we will appropriately send it to anyone who subscribed to a topic. Right. So we have two topics. We have the, like I said, the verbose and indicator. So if they subscribe to the indicator, then this piece of line, this piece of code will actually facilitate the sending. If they subscribe to the verbose, then this piece of code will send that as well. Okay, so it will actually send two messages at once in this method, which is kind of cool. Okay, so that's the high level of the socket server. Now let's touch the actual analysis of what goes on behind the scenes. So let's first get into the fall processor. So here is the method that will do all the fall analysis. Although I won't go into this, instead I will look at the mathematical model for this as well. So this is the mathematical model for how to determine if a fall has occurred based on the acceleration data and the gyroscope data. So at the start, we will see if the current acceleration is below a certain threshold. Okay, if it is, then we will calculate the acceleration and angular velocity within a half a second window. Now, if the acceleration is above the threshold, so if it should look like this, then we will go to the next step, and then we'll check if the gyroscope is above a certain threshold. And then if it is, then it passed the whole process, and therefore a fall has been detected. These are the three thresholds that I've determined. Okay, so 1.6 for the upper threshold, 0.85 for the lower threshold, and then 220 for the gyro upper threshold. That's a tongue twister. And that's how this facilitated this. Eventually, not eventually, essentially this flowchart is just converted into this piece of code. Okay. Now for the seizure detection, a little bit more complicated, of course. Here's a code to do all that stuff, right? So it doesn't look like as much code as a fall detection, but a lot of this is wrapped around mathematical objects to do a lot of the analysis for us. So for example, we have linear transformations, we have wavelet transformations, decompositions, right, using linear algebra and all that stuff. I'm using those mathematical objects to facilitate a lot of the analysis for me. But if you look at the flowchart for the seizure detection, essentially whatever I have here is what's on this flowchart right here. I won't go into it because it's beyond the scope of this video, right? There's a lot of linear algebra, statistics, and wavelet transformation in this classification algorithm, okay? So I won't go too much into it. And with all that, that should explain the socket service, right? So we're just gonna get the data, we are gonna analyze the data and determine these indicators, and then we will output the data to whoever is subscribed. Now let's get into the web client, okay? So this is this web application that we saw, okay? So let's first get into the patient list page, okay? So here's the project for the web client, and here's the main controller. So like I said, remember, if you recall, how web applications work is when you put a URL in your browser, it actually makes a request to the server then prepares the server HTML, and once the server HTML is completed, it will send the finalized HTML back to the person who requested it in the first place. So these are the two endpoints to where you can request, so the patients and the patients with the patient ID. So the patients should look familiar. So this is the patient's URL, okay? So let me put that on the side. So if someone has this URL with the patients only, it will call this endpoint. If someone has a patients with some sort of patient ID, it will call this endpoint. This is on this page, right? We have the patients tag, and then we have the patient ID, okay? So with this page, we will get the HTML within this method. So for this one, what we'll do is we will retrieve the patient information from the Mongo database, very similar to how the patient, actually, never mind. Yeah, we actually don't connect directly with the patient Mongo database because if you recall from here, the patient REST service is the one that's interacting directly with the Mongo database. We're simply making a REST call, just like the Android application, we're simply making a REST call to the patient REST service. And then the REST service is the one that's interacting with the Mongo database to retrieve the data. So if you look in this repository, so for example, retrieve all patients, you can see that if you look at the implementation, this is simply just using a REST template to get all the patients from the patient service, right? And it's the same sort of REST template that's being used in the Android application. So actually, if I go back here to make it full circle, so here, patient activity. The patient activity actually uses a REST template as well. So if I search a REST template, you can see we're actually using a REST template to facilitate the communication as well as this web application. Okay. And then the similar thing occurs for if we call this endpoint. So if we're looking at the patient details page, we are just getting the information for a particular patient because we don't need all the patients. Only for the patient list page do we need all the patients, and that's why we retrieve all patients. For this endpoint, we just need to retrieve a single patient, and then we will add it to the web page. Okay. So that's for the web service part. Okay, so that's for the backend part. Now let's get into the front end. So how do these patient list page and patient details page look like? Okay, so it happens to be in this template folder. So let's look at the patient list page first. So here is the patient list page. So if you look back on the actual HTML page, we just have a list of all the patients. So here is a nav bar. So that's the nav bar you see on the side. And here is the all the patients. Okay. So for each patient in the patient list that we've retrieved from the controller, from right here, this is the patient list, right? We will display this sort of panel. Okay. So we have this panel, we have the patient name, so this is the name, and then we have all the information for that patient right here. So this is the patient information. And then we have the status indicators, and that's defined in this HTML code. So that's these two, okay? That's the HTML code for those two buttons. But now where's the JavaScript code to actually change these two statuses? I think that's a plural for status, I'm not sure, but so here's a JavaScript code. As you can see, we need a WebSocket STOMP client to be able to facilitate the STOMP connection. So that's why I used WebStomp to do that. So here we have the STOMP URL. We will connect to it, and we will subscribe to the appropriate topic. Right now we're subscribing to the indicators because we only want the indicators. We don't want the verbose, right? If you can see down here, we're only connecting to the indicators, right? Now, if we retrieve a message, right? So on the WebSocket server, if it sends out a message to anyone who subscribed to this indicators, right? Then we will analyze that data. So if the message, so for the physical status, that's if there's a fall or not. If the physical status is good, so no fall has occurred, we will change the indicator to be a OK circle. So that's a green OK circle, okay? If it's emergency, so a fall has been detected, then we will change it into a red circle, okay? The same thing is applied for the mental status. If it's a good, then it's going to be green check mark. If it's emergency, it's going to be a red X mark, okay? So that's how that works on the patient list page. The patient details page, as you can imagine, is going to be a little bit more complicated because, well, we have the same exact thing from the patient list page. We have to do these two indicators, but we also have to do it for the verbose data as well. So that's for the different plots. So let's look at the patient page. Let's go all the way to the top and let's analyze the HTML code first before we get into the JavaScript. So here's an navbar, right? I'm not sure if I can highlight it. Yep. So this is a navbar. So that's right here. And here is a header that we saw from the patient list page. So we just have the patient name, the patient information, and all of that stuff. Okay. And then here are the indicators. So we have the Muse indicator, and we have the mental indicator right here, and the physical indicator right here. So that's what these two things are. Okay, and this is the panel body. So now we're getting into these plots, and we're going to have the table. We're going to have a table for the status. So that's this table right here. We're going to have a div for the acceleration plot, a div for the gyro plot, and also a div for the EEG graph plot. Okay, so that's what these three are. We're going to actually configure the plot in the JavaScript. And then we just have the footer, so that's this right here. So we can go back to the patient list. As you can see, we have a button for that. Okay, so that's the HTML code. Now let's get into the JavaScript code. So here's the JavaScript. Here we're defining the configuration parameters for each of the plots. So here's the configuration for the acceleration plot. Here's the configuration for the gyroscope plot. And here's the configuration for the EEG plot. As you can see, this is being facilitated using the Plotly JavaScript library. All right. And then we actually attach the plots onto the HTML code. That's what we're doing right here using D3. So now if you go below, now here is when we get into the STOMP connection. All right. So we're connecting to the STOMP service that we've already discussed before. So we have a listener for the Muse verbose endpoint. So if you look back on the diagram, this is this communication that's going on right here, the Muse verbose. And here is we just have a bunch of logic to be able to attach any new data that's being retrieved from the verbose and actually put that in the plot. So that's what's going on all the way in this code block. I won't get into it in too much detail. Now here is the subscription for the Muse indicator. So as you can see, we have two communications that's going on. We have one for the verbose and one for the indicators. So this is the one we're talking about right now, the Muse indicators. So in this one, this is similar to the patient list page where we just retrieve the data and then we change these indicators that occur above here. Okay. So I believe we went through all the code in the Muse Monitor system. We went through the Android application, the REST service, the socket server, and also the web client. Hopefully you learned a few things out of this video. If you have any questions, please post them in the comment. Also, you can subscribe to my YouTube channel for more videos just like this. You can also subscribe to my Twitter account @CodingBash for tweets about development. Thank you for watching, and I'll see you next time.